Hello, my name is John Michael, and I'm gonna be going through my assignment 3, and I'm gonna go part by part. So I'm gonna go from part 8 to part B. Okay. First part 8. We're just we're just printing and showing the images of the car, right? With the array, testing out whether or not if we could really show the output of it and like maybe test and see which is if the kernel can see which angle is what, right? Um, for example, uh, this here, line detection, we're seeing if the image could see the line detected, um, horizontals, right? Vertical from 45 degrees. And to really see the lines, we got to put it in the gray mode, right? So once it's in gray mode, we see the lines, right? And then we can really see which one's 45 degrees. So starting off with the first question is, can you see it with 45 degrees in the kernel applied to the car with the image plot? And we do that by doing this, right, with the NP array, a specific NP array to see which one's 45 degrees. Put it inside the transferring horizontal. That's what I named the uh, value. Once we do that, we plot and we show it in a gray form, and we see the lines in a 45 degree, right? We see some lines are aligned 45 degree compared to the one on top, where it wasn't really highlighted. Um, but once, but yeah, this is the 45 degree line that are highlighted. Next question, same thing, but this time 135-degree lines, and we can see the differences here is that some angles are highlighted. Unlike here, the front is kind of more highlighted and the one down here. This one's more of like the bottom, 135-degree, right? It's just straight up flat. Um, Question 2, apply the following kernels to your image, right? So we had edge kernel 1, 2, and 3 for question 2, and we're going to apply it, and we see um, the image as it goes by, some lines being more highlighted and highlighted with different arrays. Part B now is basically preparing data sets, bringing, building your neural models, right? And we're going to be training our each model, and we're going to be comparing models by the layers that we input and what we have, right? So first thing first, we've added a model here, right, which is part of the pre-coded that was provided. Okay, we have 5 layers counted here. We can also see it in the summary. Okay, we have 5 different layers. Okay, we start doing a custom callback, right? And then now we start training the network and we actually see the plot of it. And based on the plot, right, this is when we start answering questions. Question 3, does the plot or the network presented sign any overfitting? And you can see over here that it does start overfitting around epoch 15, right? Um, Question 4, how many layers does this model have? As I said before, we have 5, right? What are the types? Conv 2D, max pooling 2D, flatten, dense, and a different type of dense also. And then question 5, briefly explain what the purpose of each layer is. So each layer basically filters out the value so we can get a very accurate value at the end. Um, the more layers there is, the more accurate the value is going to be outputted, obviously, right? Each value has different functions on the way they try to, what's the word? Try to filter out the value, right? So each different layer has their own different purposes, okay? Um, Question 6, basically do the same thing, but this one add a convolution to the layer, okay? So now we've added a convolution to the layer. So the layer has not one, but 2 convolutions in the layer. Basically, what's going to happen is right now it's training at the moment, so I don't have the plot, but I could tell you for sure, because I could tell you for sure that the plot is, since there's 2 here, right, then 1, we were really comparing on when it starts overfitting, right? Um, Overfitting is basically when you start asking the machine to do multiple functions where the accuracy of the AI starts to be less. Like it's gonna, the process of it getting the output of the value is gonna be less because you're asking the machine to learn too many different things, right? So if we can see here, I know we don't have the plot down here yet, but if we see that with one only one convulsion layer, we can see that that overfitting starts at epoch 15. If we were to add another one, okay, we could say that the overfitting for the plot is going to be less. I know we don't have the plot showing it, but if we were to put another one, which we are, right, the plot will show more overfitting in the earlier stages of the epoch because you're adding another layer and you're asking the AI to learn another function, and basically it's going to cause even more overfitting in the earlier stages. Okay. Um, Question 8, add a dropout layer, add to your model and run it, right? So we add the dropout layer, okay, and then we start training it. And then basically if we show the plot, it's gonna show basically um what is the purpose of the dropout layer. The purpose of the dropout layer is basically to one, make sure that overfitting is caused less into the model. Dropout is, I know, as I said, overfitting, the more layer there is, the less accuracy in the value is going to be. But the dropout layer basically makes sure that overfitting occurs less within the plot. So technically, it's another layer, but not just filters stuff out, but also makes sure that the function is helping it learn, like the neural network is helping it learn to learn more useful conjunctions, so that way it doesn't get mixed up with all the functions it's trying to learn. And that extra dropout layer helps epoch not reaching earlier but a little bit later in the training. And yeah, that is my question. That is my assignment 3. Thank you.